All right, today we're cracking open the technical report for LG's brand new AI EXAONE 4.5. And this is not just another language model, folks. This is an AI that's been taught how to both see and read the world around it. So yeah, let's get right into it.
Just think about this for a second. What if an AI could do more than just understand text? What if it could look at a super complex engineering blueprint and then turn around and visually inspect a part coming off the assembly line to see if it actually matches? That leap from just understanding words to understanding the physical, visual world, that is one of the biggest challenges in AI today.
So here's how we're going to break it all down. First, we'll cover what it even means for an AI to see and read. Then we'll pop the hood and look at its architecture, check out the specialized diet it was fed during training, see how it scored on its big tests, and finally, talk about what this all means for the real world.
You know, for the past few years, AI has gotten unbelievably good at language. But look, to solve really complex industrial-scale problems, AI needs eyes. It needs to see. The next big frontier is adding that visual understanding to its language skills. You know, getting it past the limits of just being a text-based brain.
And that brings us to this core idea, the Vision Language Model, or VLM for short. It's basically an AI that can chew on images and text at the same time. And EXAONE 4.5 is LG's very first open-weight model of this type. That means they're not just keeping it for themselves, they're actually sharing it with everyone.
So, the big question is, how did they pull it off? How'd they build it? Okay, let's dive into the architecture and look at the key pieces that give this model its power to see and to reason.
This diagram really shows you the whole magic trick. On one side, you've got the vision encoder. That's what processes the images. And on the other, you have a language decoder for the text. The really smart move here is that LG essentially took their already powerful language model, EXAONE 4.0, and bolted on this brand new custom-built vision component.
Now, this is where it gets really cool. Think of it like having two different parts of a brain that are specialized for different jobs. You've got the vision encoder, let's call it the eyes, which is a 1.2 billion parameter model built completely from scratch to understand 2D images. Then you have the language decoder, or the brain, a massive 32 billion parameter model that's an expert in understanding the 1D flow of text. They're even built differently to handle these different kinds of information. And of course, it's got to be fast. Both the vision part and the language part use this technique called grouped query attention. Now, the key thing to know is that this isn't just for speeding up the text part. They baked it into the vision encoder too. It just makes the whole system run smoother and more efficiently, like a really well-tuned engine.
Okay, let's talk about training, because a model is only as smart as the data you feed it, right? And for an AI that needs to understand things like complex technical documents, well, you can't just feed it a bunch of cat pictures from the internet.
So LG got really clever here. They used this two-stage training process. First, they threw a huge general mix of images and text at the model to get the vision and language parts to just talk to each other properly. But then, in stage 2, they switched gears and started feeding it a specialized diet of really dense, expert-level stuff. Technical documents, scientific diagrams, basically turning it from a generalist into a real specialist. So what exactly was on the menu? A ton of documents. It learned from web pages with mixed-up text and images. It learned from specially created images just to get really good at reading text inside a picture. That's called optical character recognition, or OCR. And it even learned from documents that were broken down into code like HTML.
And then came the grad school level stuff. We're talking complex math graphs, engineering diagrams, and special data designed to teach it how to reason things out step by step. They also specifically trained it on how to find and count objects in a picture, which you can imagine is a pretty critical skill for any real-world use.
And this right here is a huge differentiator. The team put together this totally unique data set to give the model a deep understanding of Korean language and culture. This wasn't just random web scraping. We're talking tourism info, content from popular Korean tech and gaming sites, everything it would need to really understand the specific nuances of its home turf.
All right, so the architecture is smart, the training diet was intense, but did it all actually work? Time to look at the report card. Let's see how EXAONE 4.5 stacks up against the competition.
First up, one of the absolute hardest tests for any AI, solving math problems that are presented as images.
On this really tough benchmark called Math Vision, it scored a 75.2. Now, I know what you're thinking. What does that number even mean? Well, on its own, not a whole lot, but it's all about context.
And here's the context that matters. That score of 75.2 means it actually outperformed a rival model that is way, way bigger. So this thing is seriously punching above its weight class. It's efficient and powerful.
Okay, next up, a category where all that special training should really pay off: understanding documents and diagrams.
On the AI 2D diagram understanding test, which is a direct measure of its specialized skills, it pulls in a really strong score of 89.0.
And again, let's put that in context. Get this. That score was high enough to beat the performance of GPT-4v, a super powerful closed-source model on the very same test. That is a massive win, and it proves that LG's strategy of focusing on document data really worked. So, let's bring this all home. We've seen the tech, we've seen the training, we've seen the test scores. But why does any of this matter? What does an AI that can read a technical manual actually do for us? Well, the researchers who built it tell us exactly what their endgame is. They see this model as a critical stepping stone towards something even bigger: vision, language, action models. We're talking about AIs that don't just see and reason about the world, but can actually take actions in it. And that leaves us with this one kind of mind-blowing final thought. We're going from AI that can talk to AI that can see, and pretty soon to AI that can do. So the real question isn't just about what this AI can do today. It's about what we're going to build tomorrow, when our AI can finally see, reason, and truly act in our physical world.